Hello, welcome. So I'm doing question 27 from chapter 9. So a billiard ball moving at 5 meters per second hits another ball of equal mass, and the first ball moves 30 degrees that way with a velocity of 4.33 meters per second. And you have to calculate the velocity and theta right there of the second billiard ball. So I've defined x is positive, or sorry, x positive is right and y positive as up. This is a conservation of momentum problem. So momentum initial equals momentum final for both the x and y. So for x, initially it's m times 5 meters per second equals so the momentum in the x direction of final after the collision of both billiard balls. So you have mvx, right, the unknown, and then v 4.33 cosine 30, and you get that cosine 30 from the right triangle, and that's a component of the velocity 4.33. And you get Vx equals 1.25 meters per second. And then for y, it's the same thing. Momentum initial equals momentum final. So this time it's not moving in the y direction at all, right, initially, before the collision, the first billiard ball, so that's why it's 0. And then it equals m times 4.33 sine theta. So that's the component that we know, that the billiard ball that's going up, or that was given. And theta is 30, yeah. And then plus m vy, so the y component. And then you get vy equals negative 2.165 meters per second. And then you just do Pythagorean theorem. So v, what you want to find, is v squared equals vx squared plus vy squared. And then you plug it in, you get 2.5 meters per second. And then the triangle right here is, that's how you find, so there's the components, and you want to find theta, right? This right up here. So it's tan theta equals vy over vx. You plug those in, you get negative 60. And that makes sense because when balls hit, it should kind of create a 90 degree angle every single time. So yeah, thank you.